Hello, I'm Mr. Bob and welcome to my Algebra 1 video series. This video covers Chapter 6, Section 6, titled Scatter Plots and Equations of Lines. By the end of this video, you will have reviewed methods for writing an equation of a trend line and for an equation for a line of best fit. In both cases, you'll be using scatter plots of data from real life situations. If you would like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, before we dig into the materials here, let's go over a couple of definitions. A line of best fit, a trend line that shows the relationship between two sets of data most accurately, is called a line of best fit. We'll address that in the very beginning. And then correlation coefficients. Correlation coefficient. The graphing calculator also gives you the correlation coefficient. We're going to call it R here, which tells you how closely the equation models the data. Okay, so let's take a look. First, I'll look at it. I'll draw a picture here. So let's draw this graph right here, and let's just say you've got data like that. Well, what we're going to do is a trend line. The trend line shows the relationship between two sets of data. The sets of data are the data that's on this line down here on the x-axis and the data that's on the y-axis, okay? So a trend line would be, and just as an example, you're going to try to find the line that most closely matches the data. Okay, that's called a trend line. And so we're going to be discovering some facts about the trend line here shortly. And R, this value R, is the value, the number that says how accurately does this line here that we've just drawn, how accurately does this line match the data that it's trending for? How's that? Okay, so if your data was like over here, with as this was your pattern, and we had the line drawn up here, up high, and truthfully the line should maybe go through here, then this line that we originally drew, the R would be very much closer to 0, where maybe the second line I'm drawing here, the R value is going to be an R of maybe 0.9 or something like that, more close to 1. So that's just to get a feel for that, okay? Okay, we're going to move on. We're going to be talking about these. So objective of 1, writing an equation of a trend line. In chapter 1, if you remember, we use scatter plots to determine how two sets of data are related. You can now write an equation for that trend line. So I just showed you that on the previous slide. And now we're going to come up with some data and we're going to try to draw a trend line. In fact, we will draw a trend line, okay? Here we go. Okay, example 1, a trend line. So what are we going to do here? It says, make a scatter plot of the data at the right. Okay, here's the table over here on the right-hand side. You see they want us to make a scatter plot of this data. Draw a trend line and write its equation. Use the equation to predict the wingspan of a hawk that is 28 inches long. So what we're going to do now is we're going to take and they have steps here for us to do. This says first, step 1, make the scatter plot, draw a trend line, and estimate 2 points on the line. So they've plotted all of the data. If you look here, let's take the Cooper's hawk, 21 long, 36 wide on the wings. So here's 21 right here, and they said it's 36 right here. This is the right there. That's the dot for the Cooper's hawk. Okay, so you're going to plot all those dots out, and then once you do that, you're going to look at those dots and you say, I need to pick a line that fits in there most closely. And you're doing it by eye. There's no machine, there's no ruler that can do this. I mean, you can use the ruler for a straight edge, but you have to look at those dots and guess where you want to put them. And what you want to do is you want to try to put that line in a way that looks like it's as close to as many of the dots as it can. There's a few, as you see there. There's one down here at the bottom that's a little, let me see right here. There's one here that's a little bit low, and then look at this one way up, it's a little high, but most of them kind of go right through the middle. So you try to pick a line, and just kind of averages them all out in your eye. And you can see what I'm talking about here. So once you do that, that's now your trend line. You draw that in. You've now drawn, and now you're going to estimate 2 points on the line. So why are we going to estimate 2? Well, we'll find out in a second, but let's find 2. We estimated in this sheet here 14, this point here, and we said 14 and 30. We said that that's a point on the trend line. Okay, so that's good. So now that's one of them, 14 and 30. In fact, here it is as you look below. 14 and 30 is one. Now the other one we chose was 19 and 39. And 19 and 39, 19 is right here. No, excuse me, right there. And you go up to 39. Here's 38. 39 is right here. So look at that dot right there. And a nice thing about that is this dot is right on the line too, right? So it's right on the line. So now we have a dot that's right on the line, and it is one of the dots. So we chose one that's really part of the data. This first one we drew over here wasn't already data. We just used the line to pick it right down here, 14-30, 14 comma 30. So now you have that. That's step one. So we have 1430 and 1939. Step two, write the equation of the trend line. So we drew it, we picked 2 points. The reason we picked the 2 points is so we can come up with the slope. So I'm going to choose this up here. Let me change the colors to, let's say, a darker color. So I'm going to say this, oops, right there, that one is the ending point, and down here is our starting point. Right there is our starting point, right? So the starting point is 1430, the ending point is 1939. So our ending point x value is 19, that's x2, and our ending point y value is 39. That's our y1, excuse me, y2. Over here now, the starting x is x1 is 14, starting y1 is 30. So now we're going to go over here to step 2, write an equation of a trend line. We're going to use the equation of a slope. M, the slope, I have to change colors again. M, the slope, is equal to y sub 2, that's 39, minus y sub 1, which is 30. Okay, here it is, 39 minus 30. And then divided by the ending x value, which is the one from up here at the top, which is 19. Here's 19, minus the 14, which is the starting x point. And then when you do the math on this, 19 on 39 minus 30 is 9. 19 minus 14 is 5. 9 divided by 5 is our rate. Okay, it's the slope. Rise and run. Okay, so now it says next use the point slope formula, or the point slope form anyways, and the point slope form of the line is y minus y1 times the slope times x minus x1. Now we have this, that's the equation. So we're going to substitute the points. So we've picked a point, okay, and the point we've picked here is we have a 30 for the y value, and that's for the y1 value is 30. We've picked the starting point right down here because it's right on the line and it's a good starting place. So we have it. Now we have y minus 30 is equal to 9/5 times x minus 14. So our x value, was 14 and our y value was 30. We chose the starting point. We could have chose the ending point. Okay. For that matter, we could have chose any point, but this is the one we chose. So now that we have that, everything's in. We've done all the substitution here. Y minus 30 is equal to 9/5 x minus 14. Okay. So then step 3, predict the wingspan of the hawk that is 28 inches. Okay, this is going to be interesting because now here's a bunch of data for hawks. And as you see, there is no hawk on the chart that is 20. It's going to be the tallest or the largest hawk we have, 28, and 22, 24, 26, 28, it's right here in this line, and we're going to go up. So it's going to be like going up here, right? The line is going to be going up, and we're going to have to find where is, if we're going to predict it, we have to somehow determine where is point, what do we want? We want point um, 28, right? 28, we're going to see that it's way up here somewhere. And the line's going to extend and come right up in here. Okay, so now what do we do? Let's predict the wingspan. So we put y minus 30, right? We know this equation is equal to 9/5 times 28 minus 14. So we're going to substitute the 28 for x. That's the value we want. We're trying to find the 28. And then we're going to simplify this side. So 28 minus 14 is 14. So 9/5 times 14. And when you do that, you're going to get y minus 30 is equal to 25.2. And now we have to get the y by itself to get the y value. What is the y value? Way out here. Okay. So to get that value, we're going to add 30 to both sides. So the y will be in it by itself. And it's going to be equal to 25.2 plus 30, which is 55.2. So the wingspan of the hawk is 28. The wingspan of a hawk that is 28 inches long is about 55.2 inches in width, so to speak, with the wingspan. And that's what would happen. So if we have 48 and we about up to here, probably about 52, and then up into here somewhere should be about 55. Okay, across that should be about the 55 point. So, but numerically, you know exactly it's 55.2. Okay, go over this a couple times. Redo the video and watch it. If anything, the more often you see this, the more it'll become obvious to you what we're doing here. Okay. Okay, here in example one, check your understanding. If you worked with me before, you know that I'm asking you now to pause the video and try this on your own. I'll wait for you, and when you come back, we'll do it together. But I'll read it to you first. Graph the data below and draw a trend line. Find an equation of the trend line. So they want you to find the equation of the trend line. And then it says estimate the number of calories in a fast food item that has 14 grams of fat. So it's going to take a couple. You have to get the line, and then you're going to have to substitute in the 14, right? And I'm going to tell you, if I were you, you don't have to. You can try, but I would say you should probably skip 7, maybe, because it's going to be hard to squeeze those in there by hand. Because this is kind of a freehand thing. Maybe you can do it. I'm going to skip it when my turn comes. So I'm going to skip 7. Okay. So, anyways, so let's go ahead and I'll pause the video and I'll wait for you. Okay, let's assume you've done that. So the first thing we have to do is graph the data and draw the trend line. So the first thing I'm going to do, I said I was going to skip 7. I guess maybe I should do 6 because that's a nice. So right, 6 is right here. First, let's put in the numbers, the data on that graph so we know what our graph is. I'm going to say we're going with 12, 24, 36. And that covers it, right? A 6 through 36. Here's our 6 number right here. I can write 6 there. And then here, I'm going to do 100. Oh, no, let's see. 200, 200, 200, 400, and 600. So that would make this one what? 700. Okay. And then, of course, that one here is going to be 100. So, and this is 0 right down here. So let's go ahead and put the first one. Now we know the first one's at 6, 276. So that's why it's going to be hard to pick these out. But 276, here's 2, here's 3. So 76 is very close to 75. So it's about 2 3/4, right? It's about right there. And it's going to be 6 and 2 3/4. So it's going to be right about Okay, I'm skipping 7, so we're going to 10. So 10 and 220. So 200 is here, 250 is there, 220 is about here. Here's 220 and 10. So 6, 7, 8, 9, 10, 11, 12. So it's about right here. Don't know for sure, but I'm going to say it's right about there. And right about there. How's that? Something like that. Then 19 and 388. So 12, 18, 19. And 388, 4, 75, 88 is right about there. So if I go straight across to about here, okay. Then 20 and 340. So 20 is 18, 19, 20, right about here. There's 6 in between, right? So this is 20 is right about here. And it said 330. So 330 is, here's 300. 330 is right in about here. Okay. And then we're going to get 27 is and 550. So 24, 5, 6, 7, right in the middle. And 550, here's 550. So we're going to go across right about here. Okay. I don't know how good this line is going to be, but we're trying. Okay. And then 36 and 633. So here's 36 and 630. Here's 50. So 33 is right in here. So 636. Okay, so let's say this is the 36, 633. Okay, that's that one. I'm going to write that in there. This is 36, 633. That's that point. Okay. Way out there. So now that we have that, so now let's go ahead and see if we can draw a line. And the line we can start right at that dot. And the reason why is if we start at this dot, it probably shouldn't, but for doing it by hand, it works out good because if you start here, you know that you can name this dot. And it's important to name a dot and have the exact numbers that you're calling it. And I'm going to say the line is going to go right through here, through that one, and through that one, and straight if I can draw it. So I'm going here. And the bottom one here is I can hit, let's see where it hits. Okay. So I'm going to draw it and it's not going to be great. Okay. Then I can draw that out there. So there it is. There's our line. Not that it should be probably touching this dot, right? Probably touching that dot. So that's kind of the line. Maybe it could have been shifted up or down a little bit, but that's where I'm gonna call it for now. So now we have that. So now we have to be able to find the slope. Okay. So this was what? This was 6. Okay. This was 10. Yes, 10 and 220. Okay. 10 and 220. So this is 10 comma 220. So now how can we find the slope? Well, what is the slope formula? The slope formula is m is equal to y2 minus y1 over x2 minus x1. And if we carry that out, what is y2? Y2 is 633. 633 minus y1 is 220. 220 over 36 minus 10. Right? So 36 minus, so that equals, and so that's going to equal what? So what do we have here? We have 633 minus 220, and that's 413. So that equals 413 over 26, right? And what is 413 divided by 26? 413, take my value here and divide by 26, and I get 15.88. 15.88. Okay, so what is that? That's our slope based on the numbers that I'm getting here. So now that I have the slope, I can now use the point slope to define the line. Point slope. And point slope is what? It's y minus y1 is equal to m times x minus x1. And if we substitute here, I'm going to say y minus y1 is equal to m, which is 1588, times x, right? And we're going to put in the, oh, I guess I should have put in the y1 here too. Well, we're just going to x minus x1. Now we're going over to the next line. So I'm going to substitute the y1 and x1. So we're going to have y minus y1 is what? Pick a dot. I'm going to pick 10 and 220. So y1 is then going to be 220 equals m of 1588, 15.88 times x minus 10. Okay, so now we have this far. This is our equation, right? So we could rewrite this and say y minus 220. So we could run this out, right? So we can say y minus 220 is equal to 1588 x minus 158.8, right? Because it's 10 times, right? So now we can move the 220 to the other side. So now we can say y is equal to, you got to add 220, is equal to 15.88x minus 158.8 plus 220. And if I say that to get the numbers right, I'm going to do 158.8, right? That's what we have, plus 2 negative plus 220. Right, I have 61.2. So I'm going to rewrite this now. Y is equal to 15.88x plus 61.2. So that's the equation that I came up with here. Okay. And then you're going to get and put in to solve for our 28, for our 14 grams here. We're going to substitute 14 for x. And we'll come up right away with the answer, which should be, let's try it. Let's see what it comes up with. It says y is equal to 1588, 15.88 times 14 plus 61.2. And so we're going to calculate 1588 times 14. So 1588 times 14. Wait, hold on, my calculator. 1588 times 14 is equal to 222.32. I'm going to write it down here. Y is equal to 222.32 plus 61.2 And when I add that up, it's going to be plus 61.2, not times, Bob. I got to put a times in there. Sorry about that. Plus 283.52. So that comes up to 283.52 is equal to 283.52. So there you have it. You've got the equation of the line. When we solve this out, the answer is 283.52 calories for that 14 grams based on our line that we drew, okay? Whether it's right or wrong, it's what we came up with. Your numbers that you did would be different than mine. Hopefully they're somewhere near, as you see, if you can see here in the slide, with using the calculator on these, it came out to 14x plus 166. And then 362 calories. So my equation didn't quite come out like that, right? Mine did not come out that way. So I've got a 1588 instead of 14, and I've got a plus 61 instead of plus 166. So my line is obviously off. So there we have it. Okay, objective 2, writing an equation for a line of best fit. So this is we're going to talk about it a little bit first before we do one. The trend line that shows the relationship between two sets of data most accurately is called the line of best fit. A graphing calculator, like a TI-84, calculator computes the equation of the line of best fit using a method called linear regression. Okay, and when you see it on your calculator, it's going to be lin, L-I-N-R-E-G. Okay, lin regression. Okay, so then the graphing calculator also gives you the correlation coefficient, R, which tells you how closely the equation methods the data, or models the data, excuse me. So the important thing here then is we see this little chart here. It says it's 0 right here in the middle. We have 0 right here. Okay, at this point, there is no correlation. Okay, so if you have a plot of data, let me draw a little graph here. And we have some data points. Okay, um, if there's no correlation between the data going this way and the data going this way, right? The data in the x-axis versus the data in the right axis. If no matter what number you put in as you're increasing from 1 to 2 to 3 to 4 to 5, that this is just wild data and it has no it doesn't changing this to a 5 isn't any better than changing to a 4. You don't know what it's going to show up. It means there's no correlation. But if when you plot this data out, it's very straight like this. It's very much a line, so to speak, right? Like that. Then the closer the dots are to that line, the more they correlate. As you go up in the x-axis, the y-axis kind of goes up at the same rate, whatever the rate of change here is, right? So that's what they're showing us here. So in a positive correlation, as your x values go positive, the y values go positive. And if it's if every dot were on the line, okay, then it would be a positive correlation of 1. But they're always never 1, so they're something less than that, right? A negative correlation is kind of the opposite. You have the x values going positive, like it's showing here, the same as this one is. But however, the y values would be going down, right? So as you go positive in x, y goes negative. It would be like starting up here. As you go in this direction, it would be like the dots would be going down, okay? And the line would be going in this direction. So that's basically the difference. As you go positive and y goes positive, it's a positive correlation. If you go positive in x and y goes down, it's a negative correlation. And that's all they're talking about there. So when the data points cluster around the line, there is a strong correlation between the line and the data. The nearer r is to 1 or -1, the more closely the data clusters around the line of best fit. We've kind of been showing you that. In later chapters, you'll learn how to use other nonlinear models, which may better describe some data. But as you see it here, this is kind of the idea. The dots are clustering around the line, and the closer they cluster, the higher the accuracy of that line defines what that data group is. Okay? Okay, good. I think you've got this. Okay, example 2, line of best fit. It says use a graphing calculator to find the equation of the line of best fit for the data at the right. Okay, and then it also asks what's the correlation coefficient. So how do we do that with the calculator? Well, if we get a TI 84 or 84 plus, any one of those calculators for graphing, so we can do this data, but TI 84 is very common. You probably have them yourself or in the school. I know our school has them, and the students all have access to them. So what they say first to do is, in step 1, use the edit feature of the stat screen on your graphing calculator. So in order to do that, what you're going to do is there's going to be a set of keys on your keyboard, and right around the cursor keys, there's a circle area with right, up, down, right, left arrows. And right next to it's going to be a stat key. You're going to push that stat key. Here's the stat key right here. You're going to push that. And then what's going to do is another screen will pop up. And on that screen, you're going to have 4 menus. It's going to say edit, and then down here, calc, and then a few others. Okay. So on that edit screen, you'll probably see below that a menu item called edit. Hit the edit. And what's going to happen is you're going to get some column data, so to speak. You're going to have one column that's going to be L1, and you're going to have a column over here that's going to be L2, and you might have one that's L3, okay, and on and on and on. So the first thing you do is you're going to move, using the cursor keys, you're going to move up to the first spot beneath. L1 will be here, 2, and 3. You're going to move up to the first spot, and you're going to do what they say. They say let 93 correspond to the year 1993, and enter the data for the years, and then the data for the cost. So the first thing you're going to do is you're going to write 93 in the first one, and you're going to hit enter, and then you'll get another, it'll move down, and then you write 94, and then you move down again, and you write 95, and on, down to the bottom, you're going to get 99, and then below that, you're going to get 100. Okay, then move over to the next column. That's all of it. You got, as I wrote, 101, so 110, 100. So then you're going to go over with your cursor key and back up to the top to this part, the piece that matches the 93, and right across, you're going to write 340. Okay, and then below that, you're going to write 369. Okay, and you're going to do that down until you get to the bottom. And the last one down here at the 100 is going to be 574. Okay, that's the last one you're going to write. It's going to correspond to this data right there. Okay, so now that you have that, you're going to hit the second quit function. Okay, and then once that's done, you're going to return to the base screen, the main screen, and hit enter. When you hit enter, this screen here is going to pop up. So now you've done all the data. It says use the calc feature in the SWOT screen, in the stat screen. So what are you going to do? You're going to, after you return to the main screen, you're going to hit stat again, and then you're going to hit calc. And then when you hit the calc, there's going to be a number down below calc. There's going to be a number of functions written. And one of them is going to say lin reg. And that's going to stand for linear regression. And you're going to select that one. Okay, boom, click it, however you click it, with your cursor, with however, your finger, maybe you have a touch screen. Anyways, then you're going to come over and hit the second quit button again, function, and then you're going to go and hit enter. And when you hit enter, this screen is going to pop up. This screen right here will pop up. And on that screen, it says linear regression. Here you see linear regression. You're going to have a y value equals ax plus b, and you've seen this many times. That is the what? the slope-intercept form of a line, and we've been studying that. So that's what you're going to use for your linear regression. And it's telling you here that your A value for your AX is 32.33333 forever, pretty much, right? And then your B term, and here's your B term, it's going to be equal to a negative 2671.6666. Okay, so that's going to be your B term. And then the last thing you're going to want to see here is the R term, right here, R. And that R term is what it was being asked for up here, is what is the correlation coefficient? Well, in our case, this 0.996450978 is the correlation coefficient. That one says how well the line that the computer generated, this was just defined right here, which is y equals 32.33x minus 2671.67, is accurately describes this data, okay, to 0.99645, right? To that decimal, or 99.6450978%. So that's basically what that's telling you. So now you have a line that function that describes a line. So now you've got your data plotted on a screen, right? And then you have a line, and that line is defined by a y-intercept, which in this case is negative 2671, and the slope of the line is 32.33. That's the slope. So now you have a good idea of that line. And then what does it say? It says, yes, right, best correlation, linear regression. So the equation for the line is y is equal to 32.33x minus 2671.67. For the values of A and B rounded to the nearest hundredth. That's what anyways. The correlation coefficient is 0.9964509, or 99.645%. Okay. You can go over this slide a couple times if you'd like. Okay, example 2, check your understanding. So you've been working with me at all in the past, you're not likely to pause the video and try this on your own. You'll need your TI-83 or 84 calculator, and follow what I've done in the past screens. You should already know how to do this. You've learned it in class from the teachers. So anyways, go ahead and do it. They want you to, I'll give you the instructions. Read the equation, find the equation of the line of best fit for this data below. Let 91 correspond to the year 1991. And then it says, what is the correlation coefficient when you're done? So we're going to get an equation of line of best fit and the correlation coefficient. So let's go ahead and do it. So in order to do that, the first thing they want you to do is, I'm going to let you wait. I'm going to wait for you. Go ahead and try it. Okay, yeah, I almost jumped the gun there, huh? And jumped ahead and did the problem without you giving it a try. So now that you've done that, so the first thing they want us to do is hit the stat key. So the stat key, if I was going to try to look at it, on your calculator, you've got the circular buttons here that are like your cursor, right? So you've got like little buttons down, up, right, left, up and down, right? So, and then right here is the stat key. There's your stat key. So push the stat key, and when you push the stat key, you're going to get a menu that's going to come up, and that menu is going to be, I think it's going to say edit and maybe calc and maybe graph, possibly. But all we care about is edit and calc. Hit the edit button, and then it's going to pop up with some menu items, and the one you want is probably the first one, and it's called edit. Select that. And then once you do that, you're going to get a screen will pop up, and it's going to have columns. What, L1, L2, and L3. And then, so what you're going to do is you're going to take your cursor buttons and you're going to move over to the far left, using it far left, and then go up to the top until you get to this one right here, this spot. And it says to use 91 for the year 91. So on the first spot, okay, and it's going to be the, here, L1, first spot right here, it's going to be 91. And then you're going to hit enter, and then you're going to put in 92. And then you're going to hit enter and 93. And then that's going to go down until you're going to get to the bottom, and it's going to say, you're going to end up saying 99. Okay, that's going to be your last entry in this column. Then you're going to use your cursor keys over here, and you're going to move to the right one and then all the way back up to the top. Okay, and you're going to put yourself right here. And then you're going to put in 4.8, 4.8, and then the next one will be 4.9, and 5.2, and 5.4, and dot, all the way down to the bottom, and 7.4. You've got your data entered in your columns. So now you're going to go on your keyboard, and you're going to hit the second mode key. And second mode will give you, will kind of bring you back to the main screen. Then you hit stat again. Then you're going to go over here and you're going to hit stat once again, okay? When you do it, this time you're going to select calc. So it's stat calc. And when you hit the calc menu, edit, and then calc. And then you're going to get a column of a bunch of functions to operate on. And one of them down here is going to be linear, L-I-N-R-E-G, linear regression. Select that. And when you do that, it's going to jump to your screen and hit enter. Way down at the bottom, hit enter, okay? I'm going to write it down here. Then enter. And you're done. What you're going to see now is that screen like you saw on the previous. In that screen, let me bring up my calculator so that I can see and write it down as it's kind of going to look. Okay. It's going to look like stat calc linear regression, enter. Okay, so it's going to say, I'm going to draw it right over here. It's going to be y, the first one's going to be y equals ax plus b, and that's our linear equation, right, for the slope intercept. And here's your a term and your b term, right? And that's the same as in the graph we're going to now show you. The next thing that comes up is a, and they're going to say a is equal to 0.32, what, 3283, and then a bunch of threes, okay? And then the next one is going to say is b, and then b is going to be equal to negative 25.347. 347 is going to be 35, right? We're going to take that up to 35. And then it's going to say r squared, and we're not going to worry about r squared. And then it's going to say r, and r is your correlation coefficient. And in this case, it's going to be 0.975136. And in percentage, it's going to be 97.50, right? So it'll be 97.5%. Okay, you with me? So there's everything you need to know. The equation of your line is going to be, they want to know a line of best fit and the coefficient. So I've given you the coefficient. The equation is going to be y is equal to a, which is 0.3, let's just round this, 33 x, and then it's negative 25, so minus 25.35. And that's your function. That's your linear function of the line that best fits that data. So if you want to now say, well, what's the price going to be in year 2000? You could now put 2000 into this equation for x's, and you could calculate it out and get some idea that it's going to be $7.50 or 7.60 or something, maybe. I don't know. We'd have to put it in to find out, but that's not one of the questions. Okay, good.